All right, this is Mr. Smith here. We're checking out section 5.3, add, subtract, and multiply polynomials. Now, all of these skills are really good. Some of them should be very logical progressions of things we've seen before. But the real skill that we want to get to eventually, and we'll see it in about a section or two, is polynomial division. That's the real skill that's going to be very useful for us as we move forward. So adding and subtracting polynomials, the key is going to be to look for like terms. We're going to be looking for like terms. And multiplying, we're going to be doing a process much like FOILing was. Okay, so here's our problem, and I apologize, these minus signs just didn't come through. And the textbook makes this big deal about, do you subtract vertically or add vertically, or if you want to do it horizontally. I'm not going to touch any of that. I'll just show you the horizontal deal. So for part A, if I have 2x cubed minus 5x squared plus 3x minus 9, and we're going to add to that x cubed plus 6x squared plus 11. Okay. And we just go through and we find our like terms, and we combine them. So 2x cubed plus x cubed is 3x cubed, right? If I have 2x cubes over here and 1x cubed here, I add them together, 3x cubes. Minus 5x squared plus 6x squared, just plus x squared, plus 3x plus, there's nothing to add with it, right? There's no other x term over there, so just plus 3x, right? Okay, if you want to think of it, it's 3x plus 0. There's nothing to add with it, plus 0x, right? And now I have plus 11 minus 9, so plus 2. Okay, we're done. So two things to keep in mind. Number one, when we add or subtract, we're looking to add like terms. And number two, we need to make sure we have this in the right order. Right? We're supposed to have this in descending order. So x cubed, x squared, x, and then the constant. Okay, nice and easy, I hope. All right, so now we can go on and do subtraction. All right, so we're going to subtract, and again, I'm just going to do part A. So we have 3x cubed plus 2x squared minus x plus 7, and then minus 8x cubed minus x squared minus 5x plus 1. Now, subtraction is a little more difficult. The key in subtraction is that we are subtracting this entire polynomial. We are subtracting the entire polynomial, and so probably the best way to think through this is to rewrite it. All right, so the first polynomial will never change. Right, this is going to stay the same. This first piece will stay the same. But now, if I distribute this minus sign in here, okay, if I distribute the minus sign in here, this becomes negative 8x cubed plus x squared plus 5x minus 1. And then I can think of this as addition in between. Okay, so all I did is I distributed the minus sign into the second polynomial. It does not go into the first, just into the second. Okay, so I distributed the minus sign into the second, which changes every sign here. This was positive, now negative, negative, now positive, negative, now positive, positive, now negative, and now I can view this as addition. And now I can go through and add these two polynomials, and it becomes much like the previous problem. So 3x cubed minus 8x cubed is minus 5x cubed. 2x squared plus x squared is plus 3x squared. Minus x plus 5x is plus 4x. And plus 7 minus 1 is plus 6. Okay. That's the idea. Again, when we subtract, we're subtracting this entire second polynomial. And so to accomplish that, we distribute the minus sign into the second polynomial. And then we can add the polynomials, or view it as addition. Okay, let me give you a problem for you to try. So why don't you guys go ahead and do the first one. If you're watching it at home, if you pause the video and work on the first one, that'd be great. Thanks. Here we go. All right, so I'm going to distribute the minus sign through to the second polynomial. Again, it doesn't get applied to the first. And so this becomes negative 2t cubed plus 3t squared minus 7. And now I can view this as addition. One thing to note, the order in here is not in the right order. That's okay. We'll start with the highest exponent, which is t cubed, and we'll go from there. So I see minus 2t cubed, and I see nothing else over here with that. So we should just have this by itself. And then I see a minus 5t squared plus 3t squared, so minus 2t squared. I now have an 8t out here that there's no other just t terms. So this will be plus 8t. And then I have a plus 6 minus 7, so minus 1. And that is the idea of polynomial addition and subtraction. If you can subtract, I'm sure you can add. That's why I'm not going to emphasize the second problem. But if you want to work on the second problem on your own, you're more than welcome to. All right. So this brings us now. This is a good problem if you wanted to practice. Again, if you're watching the video, please take your time and go through this. But let's move on to polynomial multiplication. Now, we should have seen a problem similar to the first one at some point, either in Algebra 1 or Algebra 2. But the idea here is that I'm going to take the x, and I'm going to multiply it by everything that follows in the second polynomial. And then I'm going to take the 3, and I'm going to multiply it by everything that follows in the second polynomial. And therein lies our understanding of polynomial multiplication. In this case, there will be 6 multiplications. Okay. And then, of course, we'll have to do combining like terms at the end. Okay. So, x times 3x squared is 3x cubed. X times negative 2x is negative 2x squared. X times 4 is plus 4x. 3 times 3x squared is plus 9x squared. 3 times minus 2x is minus 6x. And 3 times 4 is plus 12. And just a good check is that I expect to see 6 terms there. And I have them. So now we're going to go through and try and combine like terms. So 3x cubed is by itself. Minus 2x squared and 9x squared is plus 7x squared. 4x minus 6x is minus 2x. And then plus 12 at the end. And there we are. So when I multiplied those two polynomials, x plus 3 times 3x squared minus 2x plus 4, we get out this result. For the second problem, we never multiply 3 things at the same time. Even if I gave you something as simple as 2 times 3 times 4, none of you could simply tell me what that is like a multiplication fact. Either you're going to go 2 times 3, 6, times 4, right? Or you're going to go 3 times 4, 12, times 2. But no one multiplies 3 things simultaneously. Likewise, we don't multiply 3 things simultaneously. Okay, we'll multiply these 2 first, and then multiply by the third, or we'll multiply these 2 first, and then multiply by the third. Okay, so this will be a little bit of work, as my students are pointing out. But just be glad there isn't a 4th thing here, which is where we'll be going. So here we go. X minus 5 times x plus 1. So I'm going to put that in brackets, and I'm going to do this part first, and then I'm going to tag on the x plus 3 at the end of it. Okay, so that's going to stay there. That's not going anywhere. And so what we have is x minus 5 times x plus 1. And so I'll put this in brackets. So that should be x squared plus 1x minus 5x, so minus 4x minus 5. And so there is our trinomial. Right, that's our first part. So I've multiplied the 2 things. If you can see this is red. I've multiplied the 2 pieces in red. And now we're going to multiply by x plus 3. Okay. So now, for the second part of this multiplication, I should have 6 multiplications. Right? So I should have x times x squared, x times 4x, x times minus 5, and then 3 times x squared, 3 times minus 4x, 3 times minus 5. Okay, so there should be 6 things now. So here we go. X times x squared, x cubed. X squared times minus 4x, minus 4x squared. X times minus 5, minus 5x. 3 times x squared, 3x squared. 3 times minus 4x, minus 12x. 3 times minus 5, minus 15. So now we combine like terms. X cubed minus 4x squared plus 3x squared is just minus x squared. Minus 5x minus 12x is minus 17x. And then minus 15 goes there. And there you have it. That's how we multiply three binomials. Okay. So there are some special properties or special patterns that can be seen. The first one we've seen before, a plus b times a minus b, the middle terms drop out and gives us a squared minus b squared. This one is very important. I mean, we'll see this over and over and over again. It's probably the most important application of this is in factoring, where I give you something like x squared minus 16, and we're working our way backwards. We also have square of a binomial, so a plus b squared. Okay, we've seen this before, right? Probably in chapter 4 we would look at it as y plus 3 quantities squared. We've seen that. But now we're going to talk about it at a little bit more complicated level. But I probably would not encourage you guys to try to memorize these patterns. I mean, they can be memorized. Some of the teachers will ask you to memorize these. My recommendation is to know what they mean. All right, so a plus b squared means a plus b times a plus b. So write that out and then work it out. A plus b cubed means a plus b times a plus b times a plus b. So work it out. All right, don't try to memorize a rule, because let's face it, I think most of you would struggle to memorize this accurately. Right? We have to memorize this exactly as it is, and then we still have to do some math there. Right? So I hesitate to ask you to memorize that. Instead, know what a plus b cubed means, and then work it out. And we'll see some problems like that on this next slide. Okay. So what the textbook wants you to see is that there are special patterns here that may save you a little time if you have them memorized. What I want you to see is that you don't need to memorize those patterns. You can simply work these out because it's just polynomial multiplication. All right, so 7m minus 3 times 7m plus 3, right? 1, 2. This is literally just foiling. So we get 49m squared. If you don't see that the middle terms are going to drop out, that's fine. This will be plus 21m. Minus 21m, right? So the middle terms do indeed drop out, minus 9. So this leaves us 49m squared minus 9. Okay, right? Not bad. Here we go, next one. 4t cubed plus 6 squared is 4t cubed plus 6 times 4t cubed plus 6. This equals. Okay. So what is 4t cubed times 4t cubed? Go ahead, live studio audience, what do you think? 4t cubed times 4t cubed. Is it 16t to the 6th, or is it 16t to the 9th? So when we multiply two powers, we add the exponents. So 16t to the 6th. Okay, it's one of those rules. It was one of those properties from section 5.1 that we can't lose sight of now that we're in section 5.3. Okay, so now we keep going. 4t cubed times 6 is plus 24t cubed. We get the exact same result again. And then 6 plus 6 is plus 36. Okay. And so this simplifies to give us 16t to the 6th plus 48t cubed plus 36. And of course, if you had that property memorized, you could have kind of worked through that a little easier. But even if you don't have the property memorized, it still just falls right out. A little bit of math. All right, so the last one I'm going to ask you to do, pause the video at home, and my students in class, I want you to work on this. And this is going to be a little bit difficult, right? So first thing you see is that it's cubed, right? So that means I'm going to take xy minus 4 times xy minus 4 times xy minus 4. And remember, we don't multiply three things at once, so pick two of them, which doesn't matter which two because they're identical. So pick two of them and start going. All right, and so at this point, if you pause the video and work through the rest of this, it will require a little bit more space than I've allowed, so please be aware of that. Cool. Let me pause the video now. All right, so we'll pick up after doing that multiplication. So xy minus 4 times xy minus 4 should give us x squared y squared minus 8xy plus 16. And now we have to do this again. This time there should be 6 multiplications. So x squared y squared times xy, x cubed y cubed. xy times minus 8xy is minus 8x squared y squared plus 16xy minus 4x squared y squared plus 32xy minus 64. And so we simplify from here. X cubed, y cubed, minus 12x squared, y squared, plus 48xy minus 64. This is an Algebra 2 level problem. Okay. For me, at this moment, to make this to the 4th power would just be unkind. So I won't do that to you. But this, I would expect all my students to be able to work through. Maybe not yet, but as you work through this section. Okay. There are some more examples I have, but at this point we have covered the bulk of the material for section 5.3. And so this will conclude this video lesson. Thanks for your attention. Have a good day.